Hi, thanks for watching my video. My name is Cecil C from SingaporeStudent.com. This video is designed for students taking H1, H2 chemistry in Singapore, but overseas students can watch this video also. So this video is about volumetric analysis calculation. A lot of students are having difficulty with this chapter because it involves both the calculations in chemistry, or called stoichiometry calculation, and also some knowledge about redox reaction. I personally think that this type of calculation is not really that difficult. That's why I already prepared one very simple question about volumetric analysis that we are going to do today. So I already prepared the question here, and also I already prepared also the pattern that we are going to fill up together to solve this question. Before we continue, you can download the link from below. I already prepared only three page for of my handwritten notes about this question. It's a very simple exercise actually, and after you print it out, on page 2 we have this pattern here that you can either try to fill it up yourself, or if you're having difficulty with it, you can watch this video again and fill up together with me. So we can start by reading the question. Yeah. Okay, volumetric analysis question. 50 cm³ of a solution containing ethane dioic acid . 50 cm³ of a solution containing ethane dioic acid. The chemical formula is H2C2O4 and sodium ethane dioate, Na2C2O4. Required 39.5 cm³ of 0.1 mol per dm³ sodium hydroxide, which is NaOH for neutralization, and 64 cm³ of 0.0205 mol per dm³ potassium manganate 7 for oxidation in acidic condition at 65 degrees Celsius. Calculate the concentrations of the ethane dioic acid and sodium ethane dioate in acidic condition. It looks difficult, but it's quite easy actually. Basically, you're given an unknown, a solution with an unknown concentration of ethane dioic acid and sodium ethane dioate, and by providing you with the information of the amount of sodium hydroxide and potassium permanganate, they expect you to calculate the concentration for the unknown for the substance, which is ethane dioic acid and sodium ethane dioate. Now, if you encounter this type of volumetric analysis question, there are two things you need to. There are two basic tasks that you must do. You must be able to tell. One is you must decide how many reactions are involved. You must be able to tell how many reactions are involved in this question. Later we find out that there are two reactions involved here, which I already write, so we are going to come up with that later. The next one is the second things that you must do is also you must be able to tell the connection between one reaction and another reaction. So there's a linkage there, and if you look at it later, you're going to find out that the linkage is the sodium ethane dioate, which is the product of reaction 1 and the reactant of reaction 2. So so you have a connection there between so the product as of the reaction 1 is being used as a reactant for reaction 2. Now we can try to solve this problem together. You have two substances with unknown concentration. Very simple. Two unknowns, ethane acid and sodium ethane. We must be able to tell how many reactions. So the first one is, they give a clue here in the question. The word neutralization is a type of reaction between acid and base. Sodium hydroxide is a base, so it will react with the acid, which is ethane acid. So this block of information tell you that there is a reaction called the neutralization reaction. So that's the first reaction. Another clue, we have another reaction also. So we read here 64 cm³ of 0.025 mole per dm³ potassium manganate 7 for oxidation. So of course it indicates a redox reaction because it's oxidation. Potassium manganate 7, by now I think you know that this is a strong oxidizing agent. Then we know that the second reaction is a redox reaction between potassium manganate 7, which is a strong oxidizing agent. So there must be a reducing agent in the solution. In this case is ethane dioate ion. Now we are going to write down the chemical reaction one by one. For reaction 1, reaction 1 is a neutralization. So you have acid and base, H2CO4 and NaOH. Of course they will react. And we must balance the reaction. I already balanced this, right? 1 H2CO4 will require 2 NaOH. Very simple, because ethane dioic acid is a diabasic acid. You're going to produce 2 H2O, and you're going to produce also sodium ethane dioate, right? Okay. The next one, you have reaction 2, which is a redox reaction. So we have the permanganate ion. It is a strong oxidizing agent, which of course will get reduced to Mn2+. This reduction of equation you can easily find out in the data booklet, right? And you can balance quickly also. In the data booklet it's already balanced, so you can just copy that, and it will require 5 electrons. So the oxidizing agent, the reducing agent in the solution is sodium ethane dioate, or the ethane dioate ion, C2O4 which turn into 2CO2 and require 2 electrons. Now the next one is we fill up the information given in the question. Very simple. Okay, what information is given? Sodium hydroxide is 29.5 cm³. So we fill it up here. Of course, you must convert it to dm³. So 29.5 times 10 power negative 3 dm cube, and the concentration is 0.1 mole per dm cube. Other information: 64 cm cube of 0.025 mole per dm cube potassium permanganate. So we copy that information to the potassium permanganate in reaction 2, which is 64 times 10 power negative 3 dm cube and 0.0205 mole per dm cube. Other information: 50 cm cube of the solution. So the solution contains ethanoic acid, so we put 50 cm cube there, which is 50 times 10 power negative 3, and 50 cm cube of the available sodium ethanediol. So 50 times 10 power negative 3. Yes. Now, the next one is to calculate the number of moles of the reactants involved. I think okay, I have my calculator here. Okay, now in the case of reaction 1, we have enough information to calculate the mole of sodium hydroxide. Since we already balanced the equation, we can find the mole of ethanoic acid and sodium ethanediol. Very simple. We can find the mole of sodium hydroxide, 29.5 times 10 power negative 3 times 0.1, which is of course 2.95 times 10 power negative 3 mole. Mole of ethanoic acid, very simple, the ratio is 2:1. So we simply divide by 2, we get 1.475 times 10 power negative 3. Now the first question is very simple. They ask for the concentration of ethanoic acid. So we know the mole and the volume. We can just simply divide them. So divide by 50 times 10 power negative 3. So you get 0.0295 mole per dm cube. Well, that's easy. The sodium ethanediol produced is here. The ratio is 1:1 with the ethanoic acid, so we get the same number, 1.475 times 10 power negative 3. Now the next one. So we already answered the first one. Our answer is 0.0295. The next one is to calculate the concentration of sodium ethanediol ion in acidic condition. Our answer is not this number. This is the sodium ethanediol produced before we have an unknown concentration here. So later both of them will combine and react with permanganate ion. So the information that you use is for the potassium manganate 7. We have the volume and concentration, so we can calculate the mole easily. So just 64 times 0.0205. So then we get 1.312 times 10 power negative 3 mole. So this is the mole of permanganate ion. We can calculate the mole of electron using the ratio 1:5. So just times 5. So we get 6.56 times 10 power negative 3 mole. The ethanoic ion reacts to produce electron. So the amount of electron produced is the same as the amount of electron absorbed by permanganate. So we can use this ratio 1:2 to calculate the mole of ethane dioate ion. So we just divide by 2. We get 3.28 times 10 power negative 3 mole. This 3.28 for reaction 2 is coming from reaction 1 and the original sodium ethane dioate that is already exists. So we can just simply minus away the number to get the original amount of sodium ethane dioate. So we just minus 1.475. We get 1.805 times 10 power negative 3. And to calculate the concentration, we know the mole and the volume, so we just divide it to get the concentration. So divide by 50 times 10 power negative 3, and we get 0.0361 mole per dm cube. I think our answers are correct. 0.0361 mole per dm cube. Yes, so that's how you can solve volumetric analysis question. Initially you might find it difficult, but it's not really difficult. So remember, two main tasks for you to do. One is list out the possible reaction, right? In this case we have 2 reactions, and find the connection between the 2 reactions so we can calculate the number of moles and ultimately the concentration. Okay, so that's one type of volumetric analysis question. Hopefully it's beneficial for you. Thank you.